Okay, time to begin. So, as you know, that on my desktop I have Stat 324, and I have the data, and I have the R directories. So what I'm going to do is the following. I'm going to go to Canvas, okay, and I'm going to download those files that I just posted. Okay, Cal Poly, Stat 324. Okay, so that's that. Put my password in, not for you all to see, of course, because that wouldn't be smart. Wait, drink coffee. All right, so I think when you go to this, I'm going to move it up. Kind of interesting that it's all in the bottom. That's me. That's not what I want to move. Okay, I want to move this all the way up. And so I'm going to download these files and put them into the directory. All right, and look what directory I put it in. So put it right here. Okay, so I'm gonna download this, download functions. Okay, so this function file is complementary. At the end of the day, the file is used to help you learn more about variability. Okay, if this was a pure R class, of course, we would legitimately talk more about what's happening in the functions file, but we're not. So, so what I'm going to now do is open up my downloads. Okay, and then within the R directory, this is class notes. Okay, I'm going to create a new directory as well. I'm going to call this explain variability. Okay, once I open up that directory, I'm going to put these two files in there. Boom. So that's a little bit of working with files. Let's continue this video with some real R stuff. Okay. Oh, I already did that. Click on the R project. Okay. Click on the R project and it's going to open up the README. We can ignore that and just make it full screen. I can make it full screen. That's fine. And then what we're going to do is go to R, go to class notes, go to explain variability, and all we have to do is click on this file. Okay. And this is the file that we're going to use to learn about explaining variability. Let's see. Okay, little problem, but I fixed it. So here we go. So technically we could be working in source, but that looks it looks like a lot. So we're not going to do that. We're going to work in visual. Okay. I'm going to close this outline and just focus on this HTML within RStudio. Okay. So video one. Now finally to the statistics. So in statistics, variability is the fundamental component in terms of understanding and working with data. And we can do this within One-Way ANOVA, but there's not a One-Way ANOVA course. But this breakdown of variability into components with the residuals and the regression model is what we're after. And so when I say regression model, I'm referring to the explained variability. And then when I say the residual, I'm referring to the unexplained variability. Okay. And so what we're going to first do in this video is talk about the sum of squares total. So that's the total variability. How far does each point deviate from the mean? And so we saw this in class. Okay. This is each point. Oh, wow. Each point, yi, y bar. Then we're going to square it. Okay. But we're going to do this through R, which is going to be fun, and seeing how the numbers play a role in terms of this equation, as well as being able to see the visualization of this. Okay, so let's imagine we have 10 observations. Instead of saying index, I'm going to say student, but this easily could have been just index. Okay, the indexes. So student 1 had a score of 7 on the test. Yikes. Student 9 had 28. Okay, but the thing is, what's crazy? We do not know why these students are performing it the way that they do. We just know that these are the scores. So with that being said, we can bring in the values and the data, or at least the indexes, into R. So in bringing the data into our main utility is to find the mean. Okay, so let's find the mean. So here the index from 1 to 10 will look something like the follows. So you can just type what I type and you should get what I get. Okay, so 1 to 10. Boom. And if we want to see it, just to make sure that it actually worked, just press I and then run. And so you should be able to see our values. Because this is not a typing experience, okay, I went ahead and just gave you the data, yi, so you don't have to type it. So if you were just type underneath it or press enter underneath it, y_i, and then just run this, you'll be able to see the data. Okay, you'll be able to see the data 7, 10, 16. So these are all the student scores as seen in this table. Okay, again, the primary purpose of this is for us to calculate the mean. Okay, we're calculating the mean, but we're doing it the long way, but that's fine. So here, what we can now do is talk about the sample size, because that's one of the elements in terms of finding the mean. Sample size is going to be defined as, let me move the speaker a little bit to the right, and then let's get this going. It's going to be defined as length of yi. Okay. And then I'm going to type in. The only reason why I'm typing in afterwards is just so you can see the number. So ideally, it should say 10. Okay. But I don't have to do that to run the code, which is fine. The next thing we're going to do in terms of finding the mean is to sum all the values. So sum all the values. Come to find out, that's just a simple function. Sum. Boop. 162. Okay. So I'm going to call this the sum of yi. Sum of y. So sum y, okay, and that'll give me the sum of y. So in order for me to find the actual mean, the average is to legitimately just take sum of y, okay, and then divide it by n, and that'll be my mean. So that should be 16.2. And I'm gonna call that y bar. So we could have easily just done a function for this. There's a function called mean of a yi, what we could have done. But I legitimately want us to go through the process of, breaking down the equation, because we're going to do that for standard deviation, regression model, as well as the error. So we can get just a general pattern of understanding. So this is our mean. Y bar. Boom. Y bar. 16.2. And so what we can now do is actually visualize the data. Okay, visualize the data with this with the mean. So what I'm going to do is, I forgot to do something in the beginning, is to run this. Run this chunk. So you have to do exactly what I did. So what I'm going to do right here. So library ggplot, so we can get our visualizations. I think we also need library dplyr for us to do some working with tools. And this is the most important part. Source functions. Okay, and so I made some functions to make our life a lot easier. And so when I run this, I believe we did install tidyverse in class. This should work. If not, you can just type within the console right here in the console, install packages C. We're going to do dplyr as well as ggplot too. Okay, note what I'm doing here. So I'm installing these packages, and so I'm using the C functionality as a vector to install both of these. I'm not going to run it because I already have it. I can run it. Cancel. All right, that's fine. So when I run this, I already did. There's no errors. Okay, good. So now I can go back to actually visualizing this data in conjunction with the sample mean that we just calculated. So the function is called plot vertical y, and then I'm gonna just give it y underscore I, the actual vector. Okay, so I'm gonna run this now. Again, if you have any issues, make sure you're typing exactly what I write or type. Okay, so then here we see the mean. Oh wow, the mean of the response variable, and where that's the blue line, and all the data points in purple. Okay, in terms of this quiz scores. Okay, that's that. So the equation that we're trying to understand is composed of the data, which we talked about, is composed of the sample mean, which we just calculated, and in both of them together in conjunction can be seen in this plot. And so in terms of general statistics, what we're trying to do is understand how far does each point deviate from the overall mean? How far does this point deviate? So if I do, I think this is the place where I'm supposed to, yeah, this is the place. So if I want to see the very first value in this vector and see how far it deviates, if I put a comma 1, you can do this too, it should work. I'm going to get a red line from that very first point, okay? The second point, okay, is going to be 10. How far does it deviate from the line? If I do the fifth point, how far does the fifth point deviate from the line? Okay, and that's what we're going to do in the following equation to finally get our SST. Okay, so let's do that. Okay, so hopefully you all can see that logic with those deviation lines. That's kind of cool, isn't it? All right, so the very first thing we're going to do is find all the deviations. Okay, find all the deviations. I'm actually going to just title this deviations. Okay, deviations are going to be y underscore I minus y bar, since we already calculated it, and I want to see what it looks like. Deviations. Okay, I think that's what, right? Ooh, okay, so these are all the deviations. Okay, these are all the deviations. Like I said in class, okay, these are all the points below and above the line. Above, and below the line. And if I were to just simply sum all of these deviations, okay, does anyone know what's going to happen? Let us sum deviations. That's not what I want to press. Deviations. This should be very close to 0. That's 7.105 times 10 to the negative 15. Okay, that's not what we want. Okay, so what we're going to do instead is going to square these values. Okay, I can square these values. Okay, so then if I square, I'm going to do deviation or squared deviations. Okay, so I say deviations squared. That's going to make all the values positive. Okay, it's going to make all these values positive. Okay, so that when I take the sum of these values, sum of the squared deviations, okay, I should get 387.6. Okay, that is my total sum of squares. Our squares are total. That's how much variability is seen in this data when it comes to each value and the mean. Okay, you may be wondering, why is it, if I do 8, why is it not the 8th value? It's because it's the order of the data, and the data is not ranked from smallest to largest. Okay, hopefully that makes sense. Some smaller things to discuss. So how far does each, and some more things to discuss that we discussed in class is the idea of variance, which is just going to be the sum of squares divided by n minus 1. Okay. Put this in parentheses. Okay. And then if I want to get this in the units of, the data, what I would do is, oh, you don't know how to do that fast. Let's see if I just press a new chunk, go to C+, and click R. You can create a new R chunk. You can take this data, copy it, put it in parentheses, and square root it, and run that line. You get the actual standard deviation. That's the standard deviation. All right. So a recap in terms of this video. What we legitimately did was found how far does each point deviate from the overall mean. Okay, how far does each point deviate from the overall mean? And the particular value that we're after is 387.6. So now what we're going to do in the next two videos is to break down that value 387 into the regression model as well as the unexplained variability. So next is going to be the regression model. So stay tuned.